Welcome to day 16. The term machine learning is everywhere, right? But what does it really mean for a machine to learn? Well, it's not sci-fi, it's a totally different way of building software. Today, we're going to cut through the buzzwords and get to a simple, clear understanding.
Okay, let's start with a simple problem. How would you write a program to recognize a cat in a photo? I mean, where do you even start? Your first instinct might be to write a bunch of rules. So you might try something like, if it has pointy ears and whiskers and fur, then it's a cat. But what about a cat with folded ears? Or a cat that's just a silhouette? A hairless cat? You see the problem. Your list of rules would become a nightmare, totally brittle and infinitely long. Machine learning flips this whole idea on its head. Instead of us writing the rules, we just show the computer thousands of examples and say, here, you figure out the pattern.
And that, right there, is the fundamental shift. It's about moving away from giving explicit instructions and moving towards learning from examples. Let's really break down what that looks like. Let's use an analogy. Think of traditional programming like following a recipe to bake a cake. You have your inputs, the ingredients. You have the program, your set of instructions. And if you follow that recipe perfectly, you get a predictable output. You get the cake. The logic is all hard-coded, step by step. But what happens when the task is so complex that you just don't have a recipe? I mean, how do you write a recipe for recognizing a cat, or understanding speech, or predicting the stock market? You can't. And that's exactly where the old way of programming starts to fall apart. So machine learning is more like training an apprentice baker. You don't hand them a recipe. No, instead you show them thousands and thousands of examples of great cakes. This is what we call training data. Now, by just observing, the apprentice starts to see the patterns. That process, that's model training. And finally, when they can bake a fantastic new cake they've never seen before, that's inference. See, they've learned the essence of what makes a good cake, not just how to follow one set of instructions.
And this isn't some new idea, by the way. This was formalized way back in 1959 by an AI pioneer named Arthur Samuel. His definition is still perfect. Machine learning is the field that gives computers the ability to learn without being explicitly programmed. It's all about building systems that get better with experience, just like our apprentice baker.
Okay, so how does a machine actually do this learning? Well, it turns out there are three main ways, or three flavors, if you will. And it all depends on the kind of data we have and the problem we're trying to solve. All right, the first and most common type is supervised learning. Think of this like studying with flashcards. We give the model a ton of data where the right answers are already included. So for our cat problem, we'd feed it thousands of images that are already labeled. This one is a cat. This one is not a cat. The model's whole job is to figure out the connection between the picture and its label. Simple as that.
Next up is unsupervised learning. And, as the name suggests, this time, there's no supervisor, no labels, no right answers. We just dump a whole lot of data on the model and ask it to find hidden patterns all by itself. The goal here isn't prediction, it's discovery. Think of a big online store using this to find natural groups or clusters of customers based on what they buy, finding patterns they never would have looked for.
And last, we have reinforcement learning. This one is a big different. It's about training an agent to make decisions in some environment to achieve a goal. It learns purely by trial and error. Imagine teaching an AI to play a game. When it makes a good move, you give it a reward. A bad move, a penalty. Over millions of attempts, it just figures out the best strategy to maximize its rewards. So these three styles of learning might seem a little academic, but I guarantee you, they are powering things you use literally every single day. That spam filter in your email? Yep. That's supervised learning. The recommendations you get on Netflix or Spotify, that's unsupervised learning, finding people with tastes like yours. The fraud detection alert from your bank, that's a model spotting a weird pattern. Chatbots, digital assistants, the cameras in self-driving cars, it's all machine learning working in the background.
And this isn't just a niche thing. Even a few years ago, a Deloitte survey found that 2/3 of companies were already using machine learning. It's become a fundamental part of the tech landscape.
Let's make this super concrete with a recommendation engine. The system has no idea what a good movie is. It doesn't understand art. All it does is use unsupervised learning to find patterns. It sees that you and a million other people liked the same 10 movies. Then it notices that those million people also liked an 11th movie. So it recommends that movie to you. It's just simple, powerful pattern matching.
This is why people like MIT professor Alexander Modry say that machine learning is changing basically every industry. And if you're in tech, understanding these core ideas, well, it's not really optional anymore. Okay, let's wrap up. If there's just one thing you take away from all this, it should be this core idea. Machine learning is what happens when we stop programming with explicit rules and instead we teach computers how to find patterns in data for themselves. So your takeaway is this: learn to think in patterns, not just instructions. The next time you see a complex problem, ask yourself, could a machine learn this from data instead of me trying to write down every single rule? And that leads us to a really important and kind of tricky final thought. If these systems learn directly from the data we give them, what happens when that data contains our own human biases? How do we make sure our machines aren't just learning to automate our own worst blind spots? That's one of the biggest challenges in this field today.